Coach Jay. This is podcast 4.8. We're getting started this morning, and we're starting with the warm-up, and we're looking at how to find the other missing sides and angles when given three different things, and that's kind of what we're looking at the start here, and then we're going to go forward. All right? Rock and roll. Awesome. Keep it working. Hey David, once you solve for it, could you put one of the either sides or one of the sides up here? So I think we got all the angles, right?
Let me do B for black.
The
sorry. Can I do the B angle inside?
Yes, you can do that. That's good. I was really serious about that. Then you threw that B for a loop there.
Oh no. Never mind.
Cool. So we're looking for these three here. Awesome. Then Victoria can help you out with a little C.
Yeah, got you.
Coach Jay, I think my phone with a calculator. I left my calculator at home. Sorry,
Yeah, you can.
I'll just keep
Really,
it
Jake?
so you can see it.
Really?
Oh, or did you say your phone? Sorry, can we do this?
Oh, yeah,
I think that one does work. If it doesn't, let me know.
Try.
Jake.
Sorry.
Jake.
I watched that on Twitter
like
last
10
night.
times, Jake.
That was nice.
I was like, oh my goodness. I
Did
showed
it
it.
look like you're just like
Jake, I showed
And
it
you
to people at
showed
church and everything. I was like, he did that with no ease. I said that was with ease. I was like, I know him.
I'll let you borrow that if you play basketball.
Did you get 45 by 10
That's four.
Did you get for B? No, that's B.
Oh yeah.
Opposite over Jason is definitely B.
Oh, it's a little different, isn't it? Yeah.
So I don't know.
Cool, but same concept.
What did you get opposite over Jason in? Just do 40.5 divided by 10.
Yeah, Coach Jay,
Yeah, what's up?
You kind of confused me over here because there's different, like, in different places.
That's okay. It's okay. If you put in the different ones, it's fine. Like if you put A and B, you switch those up. That's or A, B, or C. You switch them up. That's okay. Usually keep little c on the hypotenuse because it just makes sense with c being the hypotenuse there.
Do your C again. Just 5.9 is what you said?
Yeah. Exactly right. Oh yeah, make sure that these are the got me?
Coach Jay.
C is G. Is pursued.
Oh, I'm sorry. So it should be 40.5 divided by sine of 8.4. Because when I multiply by x and divide by sine of 8.4, sine of 8.4 is on the bottom.
That the notes of the homework.
Some of you are doing the one on the homework, which is perfect. It's actually the same concept on number one. So if you're doing that on there, that's fine. I can come around and check to make sure you're good.
Coach Jay.
You'll get it.
Are those right? Because those do not seem right.
No, that's perfect. Yeah.
They're so much. They're so different. They're so different. Like the numbers are so far
It's
apart.
this one. What's angle B?
We haven't done the English. But
I think 227.2. That sounds right there. The one that I'm questioning is the B, the little B one. And the angle B there.
The angle for B
I have the angle.
I have the angle, but my V
and then
is way
C.
too big. I mean, like, of course, I keep like it's too big because like I'm not supposed to
We just
like
did the
size.
A,
What's the
right?
side of
C
C?
over Jason.
I
Basically,
know
you can side B.
especially
80.4.
The
Yes,
size.
because the largest.
40.5.
Yeah, that sounds
Yeah,
right.
oh, so that's right. Yeah.
Add
Okay, never
plus
mind.
minus both sides
I
is
put
divided
that
by
down.
10,
David, can
8.4
I have
is-
my calculator back?
Yes.
If you do it right away.
Were you
I've got to
Where's
worry
the
about
for
that
the
after
B
school.
side?
So like the first 5 minutes before I head over, you can.
What?
Let's
B
speak.
for the B side.
I see some mail, but it didn't.
The little B?
Yeah.
274.3.
That's fine.
274.3.
You come in, let's do
Get
it.
on the
We'll
notes
go
of the
over it,
homework.
and then you can just
Some
send
of the
me an
homework.
email if we don't quite finish it. Does that sound good?
Coach
If
Jay?
you send me an email, I'm good. Yes.
Do you want us to round to the nearest hundredth or
Are you
10?
sure on this one? You
Uh,
can do the thing.
10th is fine.
Got it.
Yeah, you're telling me how to do it.
Is it apps?
Yes.
I would like to
Remember how to do that. It's in the 8th, right? It's like the second.
Mode.
Oh, yeah.
Oh, you just switched your.
And you actually can just put it in as 65 degrees, 12 minutes, like that. And you can just push there's the degrees.
Oh, yeah.
So you just plug it in, it'll get you that. You don't, that is DMS form. So the only thing that you'll need to know for this is just going from just plugging in and getting out of
But if you're putting
that would be the same thing. Anna?
Yeah, you second angle.
So now we've got to solve for two things.
5 seconds.
Sides A and sides C, right? So side A would be, where we would overlook, right? Side C is the same thing, okay? Let's do this, may I write that down, is that cool? Alright, I'm gonna come to you. Hey, did everyone get this on, this part here? On the, one that's on here, some of you are doing the homework one, which is perfect. I wanna get to it, Hannah had a good question on one, I wanna make sure I hit on that. Did y'all get this on there for the notes section? Perfect, Victoria, and you're gonna write that, that third one up? Alright, as Victoria's writing that up there, did you notice on the homework, for those that did it, one of the values is extremely big. Did you notice that? I think, once we solved for it, it's like 200 something. Am I right with that? 86.4, did y'all get this one? On that section, the homework? I think so.
I got two that
You do.
Two that were super big? Here, let's
Wait, hold on,
Well,
define.
something definitely
You
gonna be
would do,
super big.
Well,
What
like
is it? What an
compared to
angle?
10.
No, but
Oh,
what
yeah,
an angle degree of 8.4.
It wasn't like
So
that at
there's,
first.
you're gonna have something that's huge because that angle is so. What's it called?
100%. Yeah, you're right.
So
Dave,
this-
and Victoria, do you have that pen?
Yes, my bad.
40.5 over B multiplied B.
That'd be funny to steal that, by the way.
That's
I
a
could
different
see
idea,
you.
Coach Jay.
No, I shouldn't have said that. Okay, hey, let's, on the homework one, I want to make sure I go through this because I think this is a good example as you're checking it. If you already get that, go to number 2. Go to number 2 over there. Up here, I'm going to make this 8.6 degrees, which was angle A, is that right? I think. Angle A. 8 point, what was it? 8.4. And across from it, side A was what? 40.5. And the angle down here, and angle B was, I don't think they gave that to us, did we could subtract from 180. 90 plus 8.4 subtracted from 180 gets me 81.6 degrees. Okay, so this is the part I wanted to make sure I hit on as we rep out one of these, right? Again, as I told Devin earlier, multiple ways to do this, right? Multiple ways. I'm just going to go over one way. So we know that, let's say A is the one that we're looking for, or looking at. We know that we have the opposite side, and let's say we're trying to find the hypotenuse side, okay? Now, here's something to remember. What is the largest angle?
Hypotenuse. I mean, sorry. Not side.
90, right? It's the C. Well, here's what we can remember. If C is the largest angle, across from it should be the largest side, okay? And since A is the smallest angle, across from it should be the smallest side. So if you forget that, that's something just to use to check as you're doing it on the test, okay? So again, if we were looking at this, we could just say sine of 8.4, make sure you're in degree mode, equals opposite, which is 40.5, over hypotenuse, which is x, okay? Now, some of you do it a bunch of different ways. If the variable's in the bottom, you can actually flip-flop these two if you wanted to, okay? Or you could multiply by x on both sides and divide by sine of 8.4. Y'all follow me on that? I think we've done this before on that.
I messed up. I did sine of the other angle.
Sine of 81.6. And how did you set that up, Andy?
I did when it was like completely set up, it was sine of 81.6 is equal to 40.5 over the hypotenuse.
I think that's where we went off just a little bit, because the opposite side, your triangle could be different and that's okay, but the opposite side of, let's say this is angle B, we don't know what the opposite side is because they didn't give us side B. So just be sure that little a and big A are across from each other, little b and big B are across from each other, and little c and big C
Okay, because on
are
the
across from each other.
there's no wait, that's right. On the problem, like right above it, there was a triangle that had A as the opposite side. So
Gotcha.
that's what
I already set up a triangle for you, didn't I, on there, on that top?
Yes, sir.
Perfect. So you could go off that if you wanted to. I'm just showing you that I could switch those around and we could still be accurate.
Okay.
As long as I set it up to where the side and angle are across from each other, we're fine. Okay? All right, so once I flip-flop this, I get 40.5 divided by sine of 8.4. Hannah, are you good now with this? And what do we get when we solve for the opposite side? In this case, we're solving for B, I believe. Side B. What would side B become now?
277.24.
Good, 277.24. And yours could be a little different depending on how you round it, and that's okay. But 277.24 is side B. And then your hypotenuse, you could solve two ways. You could do Pythagorean theorem, or you could do sine, you could do cosine of a value, as long as you make sure that you're accurate in what you're doing. So like if I use cosine of 81.6, that would be adjacent over hypotenuse, right? Or you could do Pythagorean theorem, a squared plus b squared equals c squared. So any of those ways or methods is appropriate, okay? Questions on that? Cool. All right, can we go to the next one? All right, real quick, actually one quick thing. What if I said that after I set this up, if this is 8 and this is 10, for tickets, someone help me out. What would I do to solve for the angles, the missing side? What would I do? David?
Well, I mean, like, for that missing side, C or hypotenuse, we can just do Pythagorean.
Perfect. So this would be Pythagorean.
Yeah.
Okay. Good. And Devin, what would I do to find the missing angle? Do you know? Good. And when I do SOHCAHTOA, what's one thing that you got to remember for this one that might be a little different based on my other ones? Good. Second sign, which is sine. Did I give you one? I did? Well, I'll give you two right there. That's good.
Wait, inverse.
Sine inverse, right? Or cosine inverse or tangent inverse to solve for the missing angle. Good.
Well,
That was
since,
getting deep.
and since we know we have, would you, like, not suggest us just finding it even though we know we have, like, a 90-degree angle? Because, like, we could just technically do something like...
You could run into problems if you end up using the 90-degree angle. I would say don't. That's just me. Just because you do run into problems, use the angles that are the acute compared to
Got
the
it.
90-degree angle spot. Bianca?
So you could take 90 in the given and then subtract the sum of that to 180.
You could once I solved for one of these angles. But the problem is I don't know either. And this was just an example problem. I don't know either, so I have to use the inverse to find one of them. And then I can subtract from 180 to find the
So
third.
you could take 12.7 plus 90.
You could. That was this one, right? This one was just a different one. I said what if. This was a what if. Okay. All right, good. All right, we're good here. I feel good there. All right, this is where we were at the other day. Okay, Devin. You may, yes, ma'am. All right, this is where we were the other day. Quickly for tickets, we'll go to the bottom two because this is the part that if I was concerned with on the test, these bearing problems were probably one of the parts that I would be concerned with that we really want to focus on, okay? The rest of the problems that you see on there, you'll notice there's not a whole lot of problems that are extremely challenging. I see some of you have already done them, okay? A lot of them we've already done here, but this is one that with the bearings that we want to make sure we go through. All right, question. O to C, we kind of did this the other day. What would be O to C in this example, Hannah? So this is O, right? Center to C.
Be north.
Okay, so we start with there's three parts, right? Three parts. Is it north or south? South. Is it east or west? West. Good. And then in the middle, we say what angle, when we go southwest, is connected to that south pole. So what is that angle, right? So how do we find that again? Be 74. I think we did this the other day, didn't we? We'd say south 74 degrees west, and that's how we put it there, okay? All right, Rosemary, you want to take that fourth one? What's O to D?
South.
Yep.
45
Nice.
east.
South 45 degrees east. Good, good, good. Awesome. Questions on that? Do we remember this? Okay, here we go. This is where we start getting into the fun stuff, okay? Not this. Actually, this is easy right here. Quick shout out real quick. If you've never done this before, has anyone ever heard of the City Solve Urban Race?
The city what?
City Solve Urban Race.
Yeah, I've heard of it.
It's legit. Have you? No?
Sorry.
It is legit. It is like the Amazing Race through Atlanta.
Is it
It is awesome.
what? It's like a scavenger hunt?
It's exactly what it is.
Oh.
Where does this take place at?
In Atlanta.
It sounds like it'd be kind
Oh
of fun.
my goodness.
It's a lot of
Where in
fun.
Atlanta?
It's a lot of fun. Me and my brother did it, I think it was 3 or 4 years ago, and we
My
won
kindergarten
first and won like $400.
Y'all got first place?
Yeah, it was awesome. It's really cool. All right, so as we look at this, angle of elevation, here's all I need you to know, is down here as I look up, right? As I elevate my eyes, you all know this. And angle of depreciation, do you know where that would be?
The one that's going down. Like that
This one?
Yeah.
That's where a lot of people think it is.
Oh,
It's actually-
my bad.
It's actually right here as well,
Okay.
okay?
Wait, so are there two? Like, or is that just one?
So, yeah, well, there's only one.
Okay.
There's only one. So as I look down, that is angle of depreciation, and this is angle of elevation. I said depreciation. Should be depression. Angle of depression. Okay.
So does it make a 90-degree angle with a fake angle of depression? Like, you get what I'm saying? Like, you know how you drew that straight line?
Yeah.
Does it make like
The fake angle.
like we thought the makeshift or like the wannabe angle of depression? Does it make a 90-degree angle with the real angle of depression? You get what I'm saying?
Actually, okay. So question: does anyone know how these relate with each other?
Oh, you know, it's just
they're
that,
like opposite
what's it called?
reciprocal or
Yeah,
something.
reciprocal.
They're
They
not.
make 180-degree
But
angle.
it's like
No, they
when
make
you have
90
the
complementary.
They're actually the same.
Equal. Okay, so
Oh, that's
The
what I
egg-
meant.
I
That's
was
what we
trying
meant.
to see why.
All right. So here we go.
The
That's
I will give
'Cause
11 tickets. If you could tell me what this is from geometry now.
Oh, crap.
What do we call if they're equal? What do we call? Why are they equal? And what do we call those
They're
angles?
It's,
corresponding.
no, it's because
Adjacent.
there's
They're,
like the line.
Jake, do you know? Because you were kind of
It
saying
starts
that.
with code.
Olivia, do you know?
I know they're alternate interior.
Alternate interior. That's
Oh
exactly
my
right.
gosh!
I didn't think anyone would get that. That was really impressive.
I said close.
It's
enough.
Alternate interior.
With the angle
Yeah.
of the two things.
Yeah, two parallel lines cut by a transversal. Right?
Yes.
Alternate interior.
11
Here's all you need to know: depression and elevation are the same. Cool. We got that?
Takes too bad.
That's really impressive.
Two.
I should have done that. I didn't think anyone was gonna get
What-
that.
what
That was
team you
awesome.
on?
I don't-
Okay.
I hope you're on some jumps.
I think you're on perfect column.
she's on my
Yeah.
No, that's the team that ends on.
Kurt Polynesian.
Okay, so wherever you're at right now.
I don't know.
All right, eyes up here. Here we
I
go.
think it's me.
Here's what I would like for us to do as we kind of think about going towards the end of today. As you're focused on the homework, I'm good with that. A lot of the problems that you see on the homework are not as in-depth as the problem I'm about ready to do. I need us to get one of these behind me. So this is the part that if you've been doing homework, this is the part you really want to tune into, okay? And a lot of times I like to have collaboration. At this problem, I'm just going to make sure that we get it. So I'm going to go through it myself, and if you have questions, then let me know. Because it does get a little bit tricky, okay? All right, so it says this. A ship sights a lighthouse directly to the south. Now, once I do this, one of the huge problems about any word problem is a lot of times we don't break it down, me included. We just don't break it down. So instead of taking the whole thing, let's just draw this. So we got a ship over here, okay?
Wow.
I'm
sorry.
sure you were
There must be a math teacher.
We have a sinking ship. David's in it, okay? And we have a lighthouse that's directly south, okay?
In my life.
All right, there's a little flag.
That's a lighthouse?
All right, here we go. Directly south. A second ship is 9 miles east of the first ship. Okay, so this is ship number 1. I'm about ready to cuss. I'm sorry. Okay. A second ship is 9 miles east,
right.
okay, of the first ship. Okay, so this is number 1. A second ship. I swear I'm cussing right now. All right, a second ship.
Oh, better. That was better.
This is Coach Jay's boat. Okay, is 9 miles east from the second from the first ship. Okay.
Don't.
All right, does everyone get the ship problem?
Yes.
Okay, all right, good. So we have 9 miles. That is east of the first one. All right, that's better. All right, so it also cites the lighthouse. Now, really quick, and I want to make sure we're good on this. Does everyone get how I set this up initially?
Yes.
So now we go into the next part, and this is where it gets different. It says the bearing from the second one to the lighthouse is south 34 degrees west. Now this becomes just a little bit tricky, okay? Some of you like to do your homework with colors. This might be a good time to do it, because a lot of times it becomes confusing if you don't. So from the second one to the lighthouse, you see how that is the bearing?
Yes.
The second one to the lighthouse. So, to get the full scope of this, we're going to create.
Wait, excuse me.
Yeah, go ahead. Go ahead, Dave.
Oh, okay, I get what you're saying. So the second ship has its own little X
Correct.
plus sign.
It's got its own quadrant, right?
Yeah,
It's got
okay,
its own
it. That's
angle.
what I was asking. I was like west. Never mind. You got it.
And it should make sense because it goes south, just like Hannah helped us with, south 34 degrees west. Okay? Right? So 34 degrees is not this one. 34 degrees should be this one. Does everyone understand that?
Yeah.
Okay? Anyone confused on that? Because it can get kind of tricky. Okay, good. It says, how far to the nearest tenth of a mile is the first ship from the lighthouse? Okay, so we're trying to find the first one to the lighthouse. That's X. We're trying to solve for that. I highlight, underline that to let myself know that's what I'm looking for. Okay? All right, now based upon that, I went through a lot of that without a whole lot of collaboration. But now that I've looked at this, what do I know about this and maybe have an idea of how I could solve for what X would be equal to here? What could I do? David.
Can we find the complementary angle of that 34 degrees?
We sure can,
Right
yeah.
there. So find the complement of that 34 degree
56.
angle, which would be, yep, thank you, Ann, 56 degrees.
Quick
So then let's go cos, which is adjacent over hypotenuse.
Just real quick, why can I do cosine, sine, or tangent? Why?
Why? Because that's what you use to solve these.
Because you have the angle of that one.
I
Yeah,
have
because
this
angle-
one,
yeah.
but then I only can use those for a 90-degree angle, right?
Right.
Why is this 90 degrees?
Because the two ships in the lighthouse make 90 degrees.
Yeah, because this is directly south, and then the
Right.
second ship
Right.
to the first ship is
Right.
Direct
straight across. Yeah. So that's why. Good. Keep going.
So we'll do sine of we'll do adjacent 9 over x. Sine of 56 over 9 over x.
Okay, sine of 56 equals 9 over x. All right, real quick. Can anyone raise their hand and tell me there's one thing, Dave, you rock that. There's one thing that's off with that we need to switch just a little bit. Does anyone know what that thing would be? For 2 tickets, you can tell me. Caitlin, you got it?
It needs to be cosine.
Oh,
Or-
I thought it said
And then
sine.
it needs to be x over 9.
Okay, so our second thing someone said, or Caitlin said, cosine of 56 equals x over 9. Still not quite right.
9 over x. Should it be
Rosemary?
tangent?
Should be tangent. Why?
Oh, because you don't have that. You don't need to wait for the hypotenuse.
Oh, my bad.
Yeah,
That's
because
opposite,
across
not
from here
hypotenuse. Yeah, that's
Is the
opposite.
hypotenuse from 90 degree, right?
Yeah,
So this would be my adjacent compared to my 56, and this is my opposite.
yeah, my bad.
So we would say, back here, tangent of 56 equals opposite, which is x, over adjacent, which is 9. And then how do I solve for what x is?
Do we
multiply by 9?
Yeah.
So 9 tangent of 56 gives me the distance in miles of the first ship to the lighthouse. And that's how we solve for that distance. Right? All right, questions on that? Anyone get that?
13.34.
13.34 miles. Cool? Cool. Questions off that? All right, how did that feel? Have y'all done these before? Yes,
Yes,
a little
yeah.
bit? Okay. I wanted to make sure we at least did one of those, all right? I feel pretty good. Find the angle of elevation here. I feel pretty good about that one. I think this one's off your homework, so I wanted to get to that one. Let's do this. As we wrap up today, I have 7 minutes, and then I'll give you the rest of the time to work on homework here. Is this one off y'all's homework?
Yeah.
Could you check that? Okay. I wanted to do this one because it's another bearing problem, and it's a little different from what we did. Okay, so it says an airplane is flying at 600 miles per hour and has a bearing of 52 degrees. Is that a little different?
Yeah.
Why?
You have to calculate the distance.
You have to calculate the distance. That's good. Good, Annie. Is there anyone else that saw something different there? Bianca? Yeah, the hours are different. This is true. There's one other thing. How did they give you the bearing?
It just says 52.
Oh, it's
Just
those
52.
two
It's
directions.
different a little bit. Traditionally, I'm not going to give it to you this way, but just so you're aware, if I ever say a bearing of this and there's no direction, a bearing, I don't want to give you all of this stuff, but I'm just going to have you, just for this problem, give it to you. We start from the North Pole and we go 52 degrees to the left. So a bearing starts due north and then rotates around. Okay, if it does not have a direction. Now, if it has a direction, we do it like we've been doing. But for this one, it's a little different. Okay, again, not a test question, but for this one, it will hopefully help us out here. Okay, so it goes 52 degrees with that bearing. An airplane flies at 600 miles per hour. It says after flying an hour and a half, how far north and east will the plane have traveled from its point of departure? All right, question. This is where it's headed. 600 miles per hour. How many miles did it travel?
900.
Why?
Because it's 1.5.
1.5 out, right?
Yeah.
600 miles per hour. So if he goes 1.5 hours, that'd be 900 here. 900 miles. Is there anyone questioning that? You have
Nope.
questions on that?
Don't question it.
Okay. Very good. Annie's other than Annie? Annie? Okay, good. All right, so question. How far east and north will the plane have traveled?
Time out. Didn't the plane go, that's west.
You're right.
So,
Did I get that wrong?
yeah, it's not east. Never eat soggy waffles.
I just taught y'all completely wrong.
We'll erase it from our mind.
Good. You'll erase it?
We didn't hear that. That was
I messed up completely. So the whole bearing thing, remember that?
Yeah.
I messed up. Flat simple. I messed up. When you say 52 degrees with no direction, you start at the top rotating to the right. Okay? If you do not get this, that's okay. Alright, as far as the angle and how to find that, I don't give it that way. I always give it with the direction. So we'll just put it on this side. But same idea, 900 miles. And then it goes what? It goes north. It goes east. Is that better?
Yes.
Yeah, that's better. Here's the angle. And we're trying to find how far north and east we went. Okay? And then, so if this is 52 degrees, what is theta?
38.
38 degrees, good. And what would we do in order to solve for north and east? SOHCAHTOA. Yeah,
Tan.
what one could we do?
Tan.
Tangent? Well, there's one problem with
Oh,
tangent.
sorry, not tan. We'll do no, we'll do we can do coast. Can we wait, what are we solving for? I mean, we have to do. We
I
can
like
do,
that, though. I like that.
We can do coast or sine, and then just figure out one and then use Pythagorean to get the other one. If you want to.
That's exactly right. You could do it that way. So cosine of 38 equals adjacent, which is the east, over the hypotenuse, which is 900. Again, here's the one thing. Don't, I messed up. I did. But with the 52 degrees right here, that's not a big deal for the test, okay? Just make sure you know how to do the bearing. We'll get more problems that are practice of the bearing on the review, but just kind of hold on to that as we're going through, okay? All right, questions? Perfect. Does anyone need me to continue to go through this? You want me to do it real quick? Okay, because it is off the homework, I think. So cosine of 38 equals, Hannah, what would be the ratio of this if it was cosine of 38? What would the ratio follow on that? Adjacent over hypotenuse, good. So the adjacent is E, right? Or X you could put over my hypotenuse, which is It's actually, so these are the angles. I know it's kind of weird up here. This is the angle here. This is the hypotenuse, that 900. Do you know why? Do you know why that's the case? Yeah, because it said it went 600 miles per hour. So if I go 600 miles every hour, right, as a plane, and I go for 1.5 hours, that means I have 1.5 of it, which would be 900. So it's traveling 900 miles, which would be my hypotenuse. Cool. And how would I solve for my E, or my E side? Good. So 900 cosine of 38 in degree mode would get me what that angle, or what that side would be for my adjacent. Okay. And then you could actually do the same thing with the north, except change it to sine. So if you did sine, it would be opposite over hypotenuse, which would allow me to solve for the north side as well. Okay. Cool. Are there any questions you all have on the homework as you look at it? Number 7 on the back side, star that one. That one is going to be a challenge question. I want you to try it, but I'll tell you it's extremely hard. Okay, it's extremely hard there.
If we get
A
it
good
right,
test.
if we get it right, 10 tickets.
Tell you what, if you get it right and you can bring it in and show me by tomorrow, I will give you 8 tickets if you can do that. Without copying it offline. I'm going to give you kind of scout's honor, okay? Without copying it online. Probably the bigger one's that, right? What I would do is change that to my best. You can actually do that by going to the second apps. Yeah, it's pretty easy. You go to second apps. You see how you have degrees and then the minutes? So you literally put in 65 and then 12 in that. So you get the minutes. When you press enter, it'll give you a decimal. You can use that decimal just like you did. To help you. So the change would be like your X. The change would be like your slope. So really what you're looking